Good day, everyone. The topic that we will be discussing today is about chain rule in algebraic functions. We know that the theorem of the chain rule states here that if we the f of gx, its derivative is equals to f of prime of gx times the derivative of gx. So as you observe here, we find the derivative of the f of gx, and then it is equal to the derivative of the f of gx times the derivative of the g of x. So the only concept that we will be showing, or that signifies in this kind of theorem, that it's like a chain. Kumbaga parang yung kadena ng isang scooter, or even na walang katapusang pag-drive. So ganyan ang mangyayari. So the derivative of the f of gx is equals to the derivative itself times the derivative of the g of x. So in order for this kind of example to be understand, so let's try some examples. So if we have a example number one, is if we have y is equals to 1 plus 3 of x raised to 5. So in our example, our y is equals to 1 plus 3x raised to 5. So again, let us review that when if our y, or in power rule, if our y is equals to u raised to n, automatic our derivative with respect to dx, this is equals to n u n minus 1, the derivative of u with respect to x. Okay, so this is under the power rule. So in this kind of example, I think the best method or technique to solve this kind of example is we need to use the substitution method. So let us going to let's let uh, let u is equals to 1 plus 3x. Okay, so which means that our equation, or in our given equation, will become y is equals to, and then our n is equals to 5. So our given equation will become u raised to n. And then if you derive this equation, we will undergo in here, right? So they are just the same. They are the same na. So at that point, what we need is to find the dy dx as stated in here. So we need n minus 1, the derivative of u with respect to x. So it means we need to find the n, we need to find the u, and we need to find the du dx. So as you observe here, our u, we let u as 1 plus 3x. So it means we are going to find the du dx of these terms. So easily observing this term, 1 will become 0 because it is a constant. Also 3x, and then 3x, the derivative of 3x, this is under the constant multiple rule. So x, this is equals to positive 3. Okay, so the derivative of u with respect to x, which is our u is 1 plus 3x, its derivative is equals to positive 3. So automatic, now we need to substitute. So now what we need now is we now try to substitute all our given, or what we find, which is the u, the n, the u, our u, our n, and then our dy dx. We already find its value, and then we are going now to substitute in our um, in our equation here, or in this theorem. So at this point, so we could be able to substitute now, that we could say that uh, that our y prime or dy dx, this is now equal to 5. Our n is 5, u natin is y plus 3x raised to n minus 1, so that is 4, and then our du dx is 3. So overall, our y prime is equals to, or our dy dx is equals to 15 times 1 plus 3x raised to 4. So this is already our answer. So this this method is, I use this kind of method in using substitution method. But if you are going to apply the actual chain rule, so let's try another, or let's try the same example but in the application of chain rule. So y is 1 plus 3x raised to 5. So if you're going to find the derivative of y with respect to x, we're going to apply the power rule. So 5, 1 plus 3x raised to 4, the derivative of 1 plus 3x with respect to x. Okay, so this now it falls in the chain rule, which states that if we are going to find such function or the derivative of f of gx, so we could be able to find its derivative and then the derivative of the g of x. So our so in this kind of example, we could be able to state that this is now the f of gx prime equals to, so this part, this is our f of prime gx times, and then this is now our the derivative of the g of x. Okay, so that is the chain rule. So if we are going to continue this solution, the same answer that we could that we could get in here in our first first solution, that it is equal to 5, 1 plus 3x raised to 4. So if you're going to derive 1 plus 3x, this is equals to 3. So therefore our first derivative, or dy dx, is equals to 5, 15, 1 plus 3x raised to 4. So this is also our answer. Okay, now let's try some another example. So if our example number 2, so if we have our y is equals to x squared minus 4 raised to 3. So in our first method, we are going to use the substitution method. So let u is equals to x squared minus 4. X squared minus 4. Okay, and then our n is equals to 3. So ang mangyayari, yung y natin, it will be looks like this. U equals to n, right? Our u is x squared minus 4. Our 3 is, this is our n. So now we could be able to apply the power rule. So it falls under the power rule. As you observe, this is already under the power rule because y is equals to u raised to n, and then y. So the same talaga sa power rule. So what we need is, if we're going to derive this one, dy with respect to x, our answer would be n, u, n minus 1, the derivative of u with respect to x, right? So if we are going to use this substitution technique, so we just need to, so our n is already here, our u is already present, which is x squared minus 4. So we need now to solve for the du dx. So this is du dx we need now to find the du dx, which is equals to the derivative of our u with respect to x. So we know that x squared, this is equals x, the derivative of x squared is equals to, so this is under also power rule, we bring down the 2, copy the x, and then 2 minus 1, which is 1, or x itself. And then the derivative of negative 4 is equals to 0. So now we could be able to substitute in our in this formula. So n is 3, u is x squared minus 4, n minus 1 is 2, and then our du dx is 2x. Okay, so overall our dy dx is equals to 6x times x squared minus 4 raised to 2. So if you're going to apply the just the basic concept of the chain rule, so if our y is equals to x squared minus 4 raised to 3, so if we are going to solve for the derivative, so in order to apply the chain rule, so the derivative of y with respect to dx, so 3, let's apply chain rule, 3x squared minus 4, 3 minus 1 is, this is 2, and then the derivative of x squared minus 4 with respect to x. Now it falls under the it falls under the chain rule, or it's we're in this one, this is our f of gx prime, and then here is, this is our f prime of gx, and then here this is our the derivative of gx. Okay, so if we're going to continue our discussion, overall our dy dx, this is now equal to 3x squared minus 4 squared times 2x. So overall this is equal to 6x times x squared minus 4 raised to 2, and this is our answer. Next is, let's try another example. So example number 3. So what if we have our y is equals to x squared times the square root of 1 minus x squared. Okay, so at this point, let's apply the substitution method. So let u be our x squared, v is equals to the square root of 1 minus x squared, or 1 minus x squared raised to 1/2. So they are just equal. So at this point, if we are going to rewrite the given, we could say that our y now is equals to u times v. And we could say that this is already the application of the product rule, wherein, as again, if we are going to review, if our y is equals to u times v, our derivative with respect to x is equals to v du dx plus u dv dx. Okay, so now this is already our answer, dy with respect to dx, v du dx plus u dv dx. So now our u is already here, which is x squared. Our v is already here, which is the square root of 1 minus x squared. But we need to find for the du dx first. So to solve for the du dx, so our u is x squared, so we need to, so this is our u is equals to x squared. So we need now to find the derivative of u with respect to x. So the derivative of x squared, this is just a basic application of the power rule. So 2x 2 minus 1, this is already 1. so 2x. So for the next one to solve for the, if our v is equals to 1 minus x squared raised to 2, so we could be able to use again a substitution method. So let natin let we let uh we let m is equals to 1 minus x squared, okay, and then our n is equals to 1 half. So if we are going to let, since we will let this kind of designation, what we need is, let's rewrite the given or our equation so that it will be easy to solve. So we let natin m, so this is already m, this is our n. So if we derive dv with respect to x, we could be able to solve that this is already n mn minus 1, the derivative of m with respect to x. Okay, now our n is already present, this is a 1 half. M also is present, which is 1 minus x squared. What we need now is the derivative of dm with respect to dx. So let's solve for the dm with respect to dx, which is equals to negative 2x. 1 will become 0. Okay, so at this point, let's try to substitute dx is equals to n is 1 half, m is 1 minus x squared. 1 half minus 1, this is automatic negative 1 half. Then our dm with respect dm dx is equals to negative 2x. And then the derivative of dx. So I forgot to mention this one a while ago, that this is already in our dm with respect to dx, this is already dx over dx. Because if we derive x in here, we could say that this is, since this is equal to 1, so we could be able to stop there. So in here, this is already equal to 1. So overall, our dv over dx is equals to, so positive 2, and this is 1 half, this will be cancelled out, but this sign is negative. So automatic, we have negative x over the square root of 1 minus x squared, because if we are going to bring this down, or if we put this in the denominator, this will become positive. So dx na already, so we must stop there. So this is our dv dx. So overall, if we need, so now is we are going to substitute in our, so let's substitute this one in our equation, and then also this one in our equation. Okay, so our overall, our dy dx is now equal to v is the square root of 1 minus x squared. Du dx is 2x plus u is x squared. Dv dx is negative x over the square root of 1 minus x squared. Okay, so if you are going to simplify this one, so this is 2x times the square root of 1 minus x squared plus this is, okay, this will become minus x squared times x, this is x raised to 3 over the square root of 1 minus x squared. So if we are going to continue to let's simplify this equation, so we need to let's try to find the LCD. Our LCD is equals to 1 minus x squared, so 2x This is the square root of 1 minus x squared times the square root of 1 minus x squared minus x raised to 3. So automatic. So in here, so our so if we're going to find the 1/2 2x, this is 1 minus x squared raised to 1/2 times 1 minus x squared raised to 1/2 minus x raised to 3 over the square root of 1 minus x squared. So overall in here, so since they are the same in 1 minus x squared, we could be able to fuse this one. So 1/2 plus 1/2 is already equal to 1. So we could say that 2x is equals to 1 minus x squared raised to 1 minus x raised to 3 over the square root of 1 minus x squared. And then let's try to use the distributive property in here. 2x times 1, this is 2x minus 2x raised to 3 minus x raised to 3. So copy this one, divided by the square root of 1 minus x squared. So overall our answer is negative 2x squared minus x negative 2x cubed minus x cubed. This is equals to negative 3x cubed plus 2x over the square root of 1 minus x squared. So this could be our answer. So let's try to simplify. So if we x negative x or x, let's segregate the one of the x. This is equals to negative 3x squared plus 2 over the square root of 1 minus x squared. So this is our answer now. For last example, example number 4, if we have an equation, our y is equals to the square root of ax plus b divided by cx plus d. So in this kind of example, what we need is just use the substitution method. So let's try let u is equals to ax plus b divided by cx plus d. So at this point we could be able to so we might let again, let's say that this, so if we let u, we could be able to rewrite our first example into y is equals to the square root of, okay, so we let our n is equals to 1/2. It's because this ax, this is the square root of, because this is also equal to ax plus b over cx plus d raised to 1/2. So our n is 1/2. So we could be able to rewrite this one into our y now is equals to u raised to n. So we could be able to apply the power rule, which is equals to the derivative of y with respect to x is equals to n minus 1, the derivative of u with respect to x. Okay, so at this point, to solve for the du dx, so our n is already there, and then the u is already present, which is ax plus b divided by cx plus d. So we need to find the du dx, but our u now is still under the, it is in it is rational fraction, or it is, yes, in rational fraction, which is, we could be able to our let our y, oh no, let's try to let's try to let let's try our, this is our s and this is our t. So to solve for du dx, so we might let again, let natin s is equals to ax plus b, t is equals to cx plus d. So if we can rewrite this one, our u will become s over t. So to find for du with respect to x, we could say that this is under the quotient rule, which is in quotient rule, our quotient rule, if our, this is s divided by t, this is equals to t, the derivative of s with respect to t, to x, I mean, minus s, the derivative of t with respect to x, divided by the square of the denominator, which is t squared. So now, our t is already given, which is equals to cx plus d, and then our s is also given, which is also equals to ax plus b. Now we need now to find the ds with respect to x minus, we need now to find the ds with respect to x and also the dx with respect to x. So to, um, to solve this one, so let's try, so our, so let's use this one. So our ds with respect to x, so let's use, so to derive the, let's, so if our s is equals to ax plus b, we can be able to solve for its derivative with respect to x, since a and b here is just constant. So the derivative of b is 0, and then the derivative of ax is a, and then our t is equals to cx plus d, the derivative of t with respect to x, our d is automatic, this will become 0, and then cx, the derivative of cx is equals to c. So now we could be able to substitute this one in our equation in here. So this is automatic equal to t, our t is cx plus d, our ds with respect to x, or dx is a, minus s is ax plus b, and then our dt with respect to x is c, divided by the square of dt is, this is cx plus d square. So we could be able to simplify this one. So let's try. So a times cx, this is acx plus ad minus acx, and then this is minus bc. Overall, this is cx plus d squared. So our acx will be cancelled. The remaining is just ad minus bc. So overall, this is our answer is our du dx is equals to ad minus bc over the square of cx plus d squared. So now we could be able to substitute this one. So our, so in here, so let's substitute this one. Our n is, let's go back to the first step that we did. Our n is 1/2. Our u is ax plus b over cx plus d. then our du dx now is AD minus BC divided by the square of CX plus D. So just substitute them in our first substitution, or in the first method, or the first step that we did. So overall, our dy with respect to x, this is equals to 1/2 u is ax plus b over cx plus d raised to, so 1/2 minus 1, this is automatic 1 negative 1/2. Then our du dx is equals to ad minus bc over cx plus d square. So this is our answer. Or you can simplify this one, but so this could be possible to be simplified, so just solve them. So this will serve as your homework. So simplify this one.